This problem is going to be looking at the impulse and the force that has been distributed onto the driver of this vehicle as they endure this crash. The initial velocity is 70 meters per second. The final velocity is 40 meters per second. The mass of the driver is 100 kilograms. As shown, that is a diagram. First, we have to find the initial velocity in the x direction. We do this by doing 70 cosine 40. To find the y, we do 70 sine 40. After calculating this, we found that the VIX is 53.6 and the initial velocity of y is 47. Then we have to find the final velocity on the x direction. We do this by doing 40 cosine 140 and 40 sine 140. After calculating this, we found that it is negative 30.6 and 25.7. Next, we have to find J. We do this by doing mass times final velocity minus mass times initial velocity. We'd have to find this on both the x and y directions. To find the x, we did 100 times negative 30.6 minus 100 times 53.6. After solving this, we get negative 8,426. We do the same thing along the y direction. After finding this, we have to find the J net. This equation is very important. It is the square root of J on the x direction squared plus J of the y direction squared. After plugging in these values, we end up finding that the net is 8,685.2. Now we have to solve for the force that the driver experienced during this collision. We do this by plugging in J and delta T. After plugging in all of these values, we find that the total force acted upon the driver is 7.2 times 10 to the 5th.